we're looking at intersecting circles. So we have two equations here, and they're equations of circles, and these two are going to intersect each other. Now, there's several different types of intersections. Say we have our Cartesian plane, whoops, and we're going to get our circles. I'll put on a graphing calculator. Here are some of the options we could have. So one of the options you can have is we have intersections between two spots here. So these circles intersect at two different spots. There's the other option for we have circles that have just one point of intersection between them, and then circles that have none. So this is our circle. So we already know the 2 points at 0, 3, and 3, 0. But what we want to do is algebraically prove this. So we're going to kind of number this. We have our first function and our second function, our first two equations. We want to algebraically solve where the two are going to intersect each other. So in order to do this, we're going to use a method called substitution. And essentially what we're going to do is we're going to choose one of the variables. So we have an x and a y in the first equation and an x and a y in the second one. And we need to set the equation equal to one of them. The second equation is a little easier to isolate for one of the variables. So let's say we want to isolate for the x variable in the second function. So when we do that, we're going to move y squared to the other side, so we're left with 9 subtract y squared. And then what we want to do is we want x to be by itself, so we tactically need to square root both sides here. Okay, and the square root and the power will cancel out. So you'll be tactically left with plus and minus x is equal to, you could say plus or minus the square root of 9 minus y squared. Now, because this is equal to, we really don't need the plus or minus on this side. We can just write it as x is equal to positive or negative the square root of 9 subtract y squared. So already we have two options for substitution. Okay, we have where x is equal to square root of 9 minus y squared, and x is equal to the negative of the square root of 9 minus y squared. So we're going to keep that in mind that we already have, we'll call it x subscript 1 and x subscript 2. So we have to kind of test for two of them. Okay, and when we go to test, we're using substitution. So we're taking those values we had down there and we're plugging into this first equation here. So I'm going to bring down that first equation on the right, our very first equation. And it said that x subtract 3 squared plus y subtract 3 squared was equal to 9. Okay, so what we're going to do here is I'm going to plug in the first situation when x is equal to the square root of 9 minus y squared. So in other words, we're replacing this x value with this root here. So now what it's going to read is x, and I'll kind of put it in red, or not x, sorry, the square root of 9 minus y squared, bracket, should be a square bracket, let's not use those, okay, minus 3, circle bracket, squared, plus y minus 3 squared equals 9. So now the entire goal in this is to get our y's by themselves. Okay, so there's a y here and a y here. So we want to get it by itself. We want to isolate for y. So we're going to go through this process of isolation here. So because these are squared, we're going to be kind of using FOIL. So I'm going to move over here because we're going to need this whole line. And when we FOIL this, I'm going to kind of do it a little quicker. You can do it on the side if you want. But essentially, we're doing the first terms times each other, then the inside terms, outside terms, and last term. So when I have the root of 9 minus y squared times the root of 9 minus y squared, the roots are going to cancel out. So we're going to be left with 9 minus y squared. Then root 9 minus y squared times negative 3 gives us negative 3 root 9 minus y squared. Then vice versa, negative 3 times that, same idea, negative 3 times root minus y squared. And then finally, negative 3 times negative 3 is plus 9. So we've just FOILed, okay, or we've multiplied that binomial by itself, and we end up with this set of brackets here. Okay. The other one, I'll do that quickly also, plus, and we're going to get y squared minus 3y minus 3y plus 9, and then all of this is equal to 9. Okay, so I did that a little quickly. We can collect these two like terms in the middle here and these two like terms in the middle here. And we'll be left with, and I can drop these brackets, there's nothing else to distribute. We're left with, we'll have the overarching bracket of this together. But this one we can drop these black ones here, I'll underline them. So we have 9 minus y squared. This becomes negative 6 times 9 minus y squared, and then plus 9. Okay, so we've kind of simplified this bracket here. And we'll simplify this bracket plus y squared minus 6y plus 9 is equal to 9. Okay, so now that we've FOILed all that, again, we're just distributing like a positive one, so we can drop all the brackets and start to sort our equations here. Okay, so when we do that, I'm going to start putting things together here. This y squared and this negative y are going to go to the front. So we're going to have y squared, that's what this one here, minus y squared, that's that one there. Okay, then I'm going to bring forward the root. So we have, the next thing is the root we're dealing with. We have minus 6 square root of 9 minus y squared. Okay, we've dealt with that. And then we're going to deal with this minus 6y. So minus 6y is next. Okay, I'm just underlining so that we know we've got all our terms. And then we're going to deal with, what color haven't I used yet? Green, red, blue. Okay, black. We have positive 9, positive 9, positive 9. So plus 9, plus 9, plus 9, all equal to 9 over here. We can kind of collect these like terms, okay? I'm going to set this equation equal to 0, bring a 9 over. And when we do that, we're essentially going to lose one of the 9s. They're going to cancel out. And then we have 9 plus 9 is 18. So we have, oh, and also, y squared minus y squared, they're left with nothing. So now we're left with negative 6 square root of 9 minus y squared minus y squared. The two 9s will be plus 18 is equal to 0. Okay. We kind of have a common factor of 6 here. In fact, this is a negative, and I want to make this positive. So I'm going to divide the entire equation. So every term in here we're going to divide by negative 6. So think of this like divided by negative 6, this term negative 6, this term negative 6, and this term by negative 6. So the entire equation is being divided by negative 6. These cancel out to be like a positive 1, so we're just left with the square root of 9 minus y squared. This becomes plus y, and this becomes minus 3 is equal to 0. Okay, now we have a root here, a square root. I'm going to move these two terms to the other side of the equation so that we can deal with this root. So when we do that, we're going to be left with the root of 9 minus y squared is equal to, when y goes over, it'll become negative, and the 3 will become positive. So I'm going to write the 3 first. 3 minus y on this side. Okay, so again, to get rid of a square root, well, I'm going to square both sides of the equations. This root and this power of 2 will cancel out, so we'll be left with 9 minus y squared. Here we're going to have to FOIL again. Okay, and when we go to FOIL this, we're going to get 9 negative 6y plus y squared. Okay, so now we're dealing with more like quadratic type terms we can deal with. So let's, again, I'm going to move all of the stuff over here to the other side. When I do that, we'll get, this becomes negative y squared. So that's the first one, I moved it over. This will become plus 6y, and this will become minus 9. And then we still have these two terms here, okay, which is the negative y squared and the positive 9. So positive 9 and negative y squared. And what we did, I guess I should have moved the 2 on this side here, it would have been faster. We got a 0 on this side. We've set this whole thing equal to 0. So let's collect our like terms. Negative y squared and negative y squared will be negative 2y squared. Negative 9, positive 9 cancel out. We're left with plus 6y is equal to 0. Okay. Again, we have a common theme of negative 2. So I'm going to divide every term in here by negative 2. So divide negative 2, and that stays at 0. Divide negative 2, divide negative 2. There's quite a few steps to this process. This becomes positive y squared, and this becomes minus 3y is equal to 0. Okay. I have a common. I can take out a common factor of y. We're going to essentially divide both of these by y. We're going to make that the common term. So we have y times y minus 3 equals 0. Okay. And now we think of these like two terms. This is a term and this is a term. And times each other. And to make a 0 when multiplying, that means one of them has to be 0, so we're going to test for both. We're going to split this. Okay. So we're going to set y is equal to 0, so we found one of them. And the other one is y minus 3 equals 0. And that will end up equaling, when we move negative y to the other side, negative 3 to the other side, y equals 3. So we have two answers here. Y plus 3, y is equal to 3, and y is equal to 0. Okay, so obviously we just did quite a bit of work there. Now what I'm going to do is get our two values, and don't forget, unfortunately, remember, not unfortunately, but that was only one of the options. There's also this option here. So that's going through the exact same process, but with negative root 9 minus y squared. Okay, so what I'm going to do is I'm going to do that kind of off camera and just show you the end result. It's the exact same process, but with this here. I'm going to tell you what you're going to get when you go through it. And then we're going to substitute our final answers, which are way down at the bottom here. Y is equal to 0 and y is equal to 3. Okay, so let's do that off camera here so we're not spending too much time. I did the calculations on the side, and we end up with the exact same things. Y is equal to 0 and y is equal to 3. So there was no difference when we had the negative root 9 minus y squared. We end up with the exact same y values. Okay, so now we're going to plug them into our equations. And we should be able to plug it into either of our two equations that we started with. I can plug y for 0 or 3 into this one or into this one. Now this one's going to be the easier of the two. So we're going to plug both values. We're going to do it twice, when y is 0 and when y is 3, into this and find out what our x values are. So we go all the way to the bottom. I guess it was called our equation 2 was x squared plus y squared was equal to 9. It's lagging a bit here. So first we use when y is 0. So x squared plus 0 squared equals 9. Okay. And over here, same idea. I'll write the original equation, x squared y squared equals 9. And down here we get x squared plus 3 squared equals 9. So we replaced y with 3. Okay. 0 squared is 0, so we're going to get x squared is equal to 9. Okay. And here we're going to get x squared plus 9 is equal to 9. So here we bring 9 to the other side, we get x squared is equal to 0. We square root both sides. The square root of 0 is 0. And it doesn't matter if it's positive or negative 0. Whoops. Just eliminate that. It should be x equals plus or minus 0, which is still 0. So when we plugged in y at 3, our coordinate is 0 and 3. We got that. This one here is a little trickier. Again, we're square rooting both sides, so we're going to get a plus and a minus answer. So x is equal to plus or minus 9. Now, that looks like we've got two answers. In other words, what this is telling us is we have, sorry, not 9. Root of 9 is 3. Let me make sure I fix that. That number looked off. Plus or minus 3. The square root of 9 is plus or minus 3. So we're either getting 3, 0 or getting negative 3, 0, which means we have, I'm going to count them, 1, 2, 3 points of intersection, which we talked about at the beginning. That wasn't one of the options. You either have 0, 1, or 2. So we have too many. So one of these doesn't make sense. And it's probably one of these two. So we're going to test them. 0, 3, 0, and negative 3, 0 to see if they occur in all of the equations. Now, I'm going to use some common sense. I'm going to go over here. And we know we have 3, 0 and 0, 3. You know that works. Now, we would have negative 3, 0 if we used the blue equation, right? But obviously, negative 3, 0 doesn't happen in the red one. So what I can do is I'm going to test for the red function here. That's our first equation, to see if it occurred, if this this value occurred here. So this is the one I want to test, okay, negative 3, 0. So remember, our very first function was x minus 3 squared plus y minus 3 squared is equal to 9. It'll all show up when I stop writing. Yeah, there it is. So plug this in for x and this in for y. Let's see what we get. Negative 3 minus 3 squared plus 0 minus 3 squared minus 9. This is really lagging. Oof, there it is. This will give us negative 3 minus 3 is negative 6 squared plus negative 3 squared is all equal to 9. Okay. 6 squared is 36. negative 3 squared is 9 equals 9. This says 45 equals 9. Definitely not the case. So this doesn't work. Now, we should, so we know that this doesn't work. We should test this one just to make sure also. We know this one's going to work, but I'm going to test this one just to show you where we should get two sides that are equal to each other. So, same function, I'm just going to jump right to the second step. It should be 3 minus 3 squared plus 0 minus 3 squared equals 9. Put a line through here. Okay. That becomes 0 squared, which is 0. This becomes negative 3 squared, which is 9, equals 9. And we get 9 is equal to 9, and that checks out. Okay. So our answers are, after all that algebra, 0, 3, and 3, 0 as the points of intersection. Okay. And we go over and look, and it looks like our points of intersection are 0, 3, and 3, 0. Perfect. They worked out great.